Yeah, all right. Now, nearly every math course will always start with a discussion of the number system. So you've seen this all before, so it should be a review. Let's go through it and go through it quickly. Okay. Uh, we know that following types of numbers: natural numbers, sometimes called accounting numbers, 1, 2, 3, 4, of course, going on. Whole numbers, only one up on that because you have the zero containing it. Okay. Integers, of course, those numbers which we ordinarily put on the number line, okay, coming from negative infinity, going out to positive infinity. Rational numbers, got a problem. Can't express the rational numbers, okay, because they're all the numbers in between any two integers, and then some. So the rational numbers are defined as any number that can be expressed as a ratio of two integers in the form a over b such that b is not equal to 0. Okay? Irrational numbers are those which cannot be expressed that way. Pi, 3.14, 3.156. An approximation. The exact value of pi, pi. Square root of 2, 1.41, an approximation. So irrational numbers cannot be expressed as a over b, and therefore the most exact value of expressing it is as we see here. Okay? There are other irrational numbers too as well, and we'll see them throughout the course. Okay? So the real numbers, again, is everything that's either rational or irrational. So the diagram that we'll show you will help explain this. So here's our diagram. At the very top is the real numbers. The real numbers consist of both irrational and rational. Fractional expressions, those that can't, rather, expressions that can be written as fractions and those that cannot. Okay? Integers, whole numbers, natural numbers. Here's the progression. Okay? Natural numbers are a subset of whole numbers. 1, 2, 3 is contained in 0, 1, 2, 3. Whole numbers are a set of integers, subset of integers. Integers are a subset of rational numbers. Okay? The union of irrational and rational is real. So that's a relationship, all right? If it's a natural number, is it an integer? Yes. If it's an integer, is it a natural number? No, not necessarily. Everything belongs to the set above it. Okay? We have a problem when we're talking about expressing numbers. Simple question. What is the collection of numbers between 2 and 7? 3, 4, 5, 6? Emphasis here. Is this all of them? Well, maybe yes, maybe no. The thing is, I didn't specify what set my numbers were coming from. If I now say find all integers between 2 and 7 inclusive, I have these as well as the n's. Okay? But again, come back to this. Find all numbers between 2 and 7. That might be problematic. Well, not really. Now here we go again trying to express them. Does this express them? Do we know that this implies everything between 3 and 4? What about the numbers between 2 and 3? This won't do, will it? Okay? So things like this are values that are here, but is it understood that this means these numbers as well as additional numbers? No. So the fact of the matter is that there are infinitely many numbers between any two numbers. The amount of numbers, the set of numbers between 2 and 7 is infinite in nature. How do you express an infinite set of numbers? Well, let's proceed and see how we do that. Okay? So here's the problem at hand. List all the real numbers from 2 up to and including 7. It's impossible. There are infinitely many. So you can't list them. That's not how we're going to write an expression that implies all of them. So what do? Well, let's look at a couple ways in which we can express them. This is an inequality expression. It says x is some number, is any number, meeting this condition of being in between 2, greater than 2, and less than or equal to 7. So again, x is any number meeting the condition of being greater than 2 as well as being less than or equal to 7. So that implies all the real numbers between 2 and 7 inclusive. Okay? Maybe another way is to go to the number line and express them as a piece of the number line. So here's a number line, kind of crude, I apologize, but here's the beginning part of the set of numbers. This is the interval of numbers between 2 and 7. Okay, since we're not including 2, we're going to have an open circle there. Since we are including 7, we're going to have that filled in, and we're just going to fill in that portion of the number line which applies. So this is an inequality way expressing all the numbers between 2 and 7 inclusive. This is, okay, a graphical pattern. Your book sometimes uses this graphical pattern. This is implying, okay, the not inclusive of 2, inclusive of 7, parentheses and bracket. Even a better way of expressing that is just to use the parentheses and 7 down here, as is this is the interval of, this is what we call an interval notation, representing all numbers greater than 2 and less than or equal to 7. So we borrow from this, but we just write it as an interval. So if we come down here, this is implying, okay, is the open interval, okay, what does this imply? Is this the open interval from 4 to 7? That should have been 7 there, my apologies. Okay, or is it the 0.47? So that could be a confusion. Again, that should be a 7 there, my apologies. So in the context of what we're talking about, this means all the numbers from 4 up to 7, which would be expressed in this notation with a 4 here, a 7 here, okay, and a less than, and we would wipe out the bar here. That would imply that set of numbers, okay? So that's how we're able to express infinite sets of numbers.